system call is made, the user part uses the program, and the system call is made to the kernel, and kernel basically captures the system calls, and they process it, you know. So that's how the system call is it works. So just a second, I got something something stuck. So let's see. Yeah, let's. Oh, that's not the right thing. I mean, I'm not looking even the right thing in the book. Just a second. Bear with me. So when the kernel caches a system call, how does it know which system call it is supposed to carry out? So any suggestion, any comment regarding that?
Doesn't it go by some whatever privileges it has, whatever privilege level it has, and uh then it talks to the kernel, and the
Yeah,
CPU does some variable to see which one goes first.
yeah. So I mean, that's right. I mean, it should maintain registry. I mean, basically there is a cache. I mean, cache. What is cache? Cache is a temporary memory, right? It's a you restart the system, everything is gone, all the caches are gone. But when it is on, then kernel caches all the system calls. So it caches a system call. Um, so how does it know which system call it is supposed to carry out? So there is a program, right? So you have a system call, and then you have an incoming system call in place. So then what you do is that you map system call, I mean incoming system call with the one that is already cached. It's same as the way you upload the web page. So what happens when you go to google.com from your Chrome browser, it first starts to restore it from your cache, you know. So once it is in the cache, once it is inside the cache, it finds the google.com. Sometimes you will see that even if your internet connection goes away, you will still see that Chrome browser is showing your Google web page. When once you try to reload it, you will find it is not working. So basically, whenever a system call is made, kernel will, I mean, system call request is made by the user. Kernel will see if that similar call is there in its cache. So that's how it knows. Basically, it has the cache. I mean, the it organizes the cache like least use, I mean the most used caches in the top, things like that. And then it will see that yes, this system call is here. Then it will so basically it will compare. There is a, I mean the system calls have some like some program, I mean there is some signature, some table, some mapping in the kernel. So that's how you I mean the kernel knows that there is a system calls, and it needs to handle the system call. So that's how it is done. Basically, to tell it in a very simple manner, system call interface is very tightly coupled to the kernel, you know, and the system call interface is standardized. I mean, so uh, so it will have um, I mean, if you standardize the system call interface, then you will have less flexibility on the design of the kernel. So what happens is that whenever you make a system call, kernel compares that call with something in the cache. You make a system call now, that system call goes to the kernel's cache. You then after 5 minutes you make the similar system call. then kernel will not start it from the scratch. It will basically see, well, this call is stored in the cache. Let me do it. It's the same way, as I said, you upload it. I mean, your browser loads the google.com. It's almost the same way. So that's how it is done, and that programming support is there in the Linux operating system, and they are using multiple ways to cache. I mean, there are different data structures in use. Mostly they use like most used caches in the top and least used caches, I mean least used calls in the bottom. So that's how they organize the cache, so that your visiting time is minimum, your iteration time is minimum, because there can be thousands or more system calls associated with some event in the operating system. So that's pretty much it is. Okay, so basically, so what is the answer to this question? I would say that you should approach the answer to this question in in this way, that the system call, there is a system call number associated, some identification number associated with each of the call. Kernel basically stores those number, and then once the original system call comes, it compares the that number with something on the cache. So that's how it knows that this this is something stored in the cache and this is that system call. So basically that's the way it uses that. Any confusion? Any comment? Okay. So next question is, what does the following Linux shell pipeline do? Grep RT XYZ WC dash. So why don't you try it on your Mint? I think this is a great way to do the hands-on. So let's I can do that. I can share my screen, but I have to open all the way from VirtualBox.
You know, I've tried it. If you, I can tell you what I would did while you was
Okay.
doing it. Oh,
Okay.
well, I typed it in, and then it just shows like three numbers, 000.
Okay. So what does it mean? We have to find out what does it mean, right?
I guess
Well, it's looking, I think it's looking for those two letters R and T in order. And it's gonna produce the number of words that have those in that file, which is named XYZ, and they'll produce the word count for the number of words that have that sequence of R and T in that file. Is that correct?
Yeah, I think so. Because R and T, these are two arguments, right? The grape. So grape. If you do, I mean, I think you were handling it right way, in right way. But I think we need to understand what are the arguments of grep. I mean, you see that we put grep, RT and XYZ. So what you were saying is that it is looking at the file XYZ. Is that what you were saying?
Yes, I say it's looking at file XYZ for different repetitions of the letters R and T, like Dart or report, I guess. And then it would say, hey, there's three words that have that letter sequence in them.
Yeah, that's true.
Yeah.
But what happens if your XYZ is not there?
then it won't show
Well,
nothing.
then is that XYZ is the file, right? In this case, in this
Right,
example,
right.
XYZ is just the file name.
Right.
I think, right?
Yeah, of course.
Yeah, and
Because
RT is the sequence that it's looking for throughout the file. And then and then it'll return the number of words that have that letter sequence, I believe.
yeah. So
Hey, John,
yeah, go
he
ahead.
was asking, what if you didn't have that XYZ text in there anywhere or file?
Oh,
Then-
I mean, I assume it would default. I don't know. I assume you've got to identify a file. I mean, maybe it searches the entire database. I don't. That would be kind of ridiculous. Maybe I don't know.
So if you execute it, what does it doing? I mean, did anybody execute it?
I'll try it again. Yeah,
Yeah,
well,
I made a
did it.
file just to run it.
So basically the signature of grep is it works as follows. You put grep, then you put some argument. It can be anything. I mean, it can be the matching criteria basically. And then you have the file name. So you are right, Jonathan. I think you were mentioning about this, that your uh, last argument, the third argument is the file name. You are right in that. Yes, that is the file name. So if the file name is not there, then I don't think you should be able to see anything, right? I mean, if it is not there, it's not there. Let me try that comment as well. I mean, you can put any wild file name there, like grep abc file name, let us say. You can tell. So if you do that, let me try it. Actually, my mint is there right now. So if I do grep abc, oh my sir. Okay, grep abc test. So if it is not there, it's not there. So if you do wc dash, then you have 000 because nothing is there. Now,
Yeah, that's what I got too.
right? Yeah, because it's not there. So if you do nano, let's say test, let's say we put here, what happened here? Edited by file test is being edited. Oh, okay. It is already there. So I can put it A, B, C, D, E, F, A, B, C, let's say. Let's put that sequence. I'm just testing the system. So if it is done, then if I do it right now, so you see here, you have one. So basically what happens here, so 12. So what does it mean? How many, so if you go there, ABC, ABC, so why it is 3 and like that sequence? Let's try to understand that. What is 1? 1 stands for ABC. So basically, it first matches ABC, and then why it is 3? Because your third word in the file is ABC as well, right? And what is 12? That I do not know. That is the, I think that is the
All the
total number.
characters.
Yeah, total
Oh.
number of characters, because 1, 2, 3, 4, 5, 6, 7, 8, 9. What happened? 4, 4, and but why it is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe I put an additional character there. So if I do C again, ABC, I put there. Let's see what happens. So this way you see there. So 16. So there are the ABC, the last ABC is at the 4th place. I mean, if you, it parsed the entire sentence and it found ABC in the first place, ABC in the 4th place, and then it also, I mean, added up the things. I mean, added up how many letters are there, and 16. I think that's the right. I mean, that's the right way to answer this question. So did you understand? I mean, this is ABC, and it is finding the match in here. So this is test. I mean, grep ABC test from this file test. It finds ABC, and then suppose you don't do that. I mean, you put like that. So you see, you have total how many matches? 1, 2, 3, 3 matches. So you have number 1. First match occurs at number 1. Fourth match occurs at word number 4, and then then finally you are doing the word count, and word count you are counting. I mean, there are 16 total spaces, and then you have 16 letters altogether. The spaces are also letters, and then dash is a pattern. So that's what you see there. So you are reproducing a dash at the end as well. So that's, I think that's the way it works. I mean, this pipe is basically, it's a filter. It works as a filter, or it works as a criteria. Rather than filter, it's a criteria. If you do the grep, that means you are basically searching something. Now on your search, the pipe, the pipe symbol basically classify your search. Basically qualify your search with some criteria. So that's what WC is doing. So it is asking after the pipe, it is asking, well, what are you doing? What do you want to do there? So it finds WC. So it's a different comment. So it is calculating the number of characters basically, and then it follows a pattern dash. So what happens if we put, let's say, tilde here? So so what is going on here? Oh, that is a directory. That's why the problem. So if you put a dot, it is a dot. This is a directory. That's the problem. So it is. So if you vary it, it changes. So what stands for dash? It is really. We have to understand it as well. Why if we put the dash, if we change the number of dashes, why things changes. So we can talk about it later. I will have to look into it in some details. Different pathologies of the comments we need to study. Let's say we put a exclamatory sign. There is no such file or directory. So it is trying to find some file names and something like that. It looks like, but we'll take a look at it later. But basically, first three arguments are very clear. You have it in the first place, you have it in the fourth place, and you have it in the there are 16 total characters in there. So let's see what else is there. What are zombie processes? Does it make sense to take away a process memory when it enters zombie state? So that's a good question. What do you think it will be? What is a zombie process? Any clue?
I think I got it to where it's like a process. Is it like a process that was completed and then it exited?
Yeah, maybe it could be a runaway process as well. Out of control, or something started up
And then it
accidentally.
dies?
Yeah. So I mean, okay, that's some so basically what happens, you started a process, and yeah, some runaway process is the correct answer here, because suppose a truck is running on the road, and then it fails to stop. So then we call the truck as runaway truck, right? It cannot stop within a certain distance. That's why you will see that there are loops. They create some slopes, and they put a mark on the road that runaway. This is for the runaway trucks. So the zombie processes are the processes. Basically, what happens? Original process is terminated or finished, but that remains. But the problem is the stress of the process, the identity of the process remains on the process table. Think about it. Like yesterday, we were trying to remove something. We were trying to remove a package, and then you found that the process was not ending ever, never ever. It was hanging there until you put a control C, right?
Like an
So
infinite loop, kind of, sort of.
yeah, so that became a zombie process basically. That we were doing remove a some we were using the dpkg, not dpkg, apt get, and then remove some command. We were trying to remove Apache 2,
Yeah, that was
and
it.
right, and then we found that it takes enormous amount of time, and then after the break also we found that that is still hanging on your computer, your Linux operating system, your system. So that became a zombie process. So what happened? The process originally completed, but the traces of the process, some memory did not clear up, so that the process remains on the process table. So how did you get rid of that? Do you remember?
You have to use some kind of escape or something to break to break
Control
the pattern.
Control C, right?
Yeah.
So basically you had to break the parent process. The parent process was you issued that command, you press the keyboard. So there was a parent process that initiated that particular remove process. So once that keyboard, I mean the keyboard event is interrupted. So your parent process in that case is the keyboard event, and you interrupt that process and then it went away. So basically, zombie process is a terminated, or I mean, it's a terminated process or a process that is already completed, but that remains in the process table. Sometimes you will see that whatever operating system you are using, it doesn't matter. It applies to any operating system. You ran into some slowness. There are there are system failures everywhere. You cannot upload your website. I mean, you cannot upload Google Chrome. You cannot run Google Chrome. You cannot run anything. Whatever you click, that stucks. Then what happens? You open up your task list, the list of process on your operating system, and you try to forcefully kill some of the processes, but it doesn't go away. Like even if you sometimes we see that even if we terminate the Chrome, the you will see that the slowness doesn't go away. So basically what happens there is that due to some excessive activities with some program, something, some caching, something, some imperfection, I don't know what it is, but a given process becomes a zombie process. Means even if you terminate, the traces of the process, the ID of the process remains on the process table. So your process table doesn't know that it is there. So your process table, your kernel is still allotting memory for it because it is on the process table. As a result, some of the CPUs, some of the memories are allotted there, so you won't get any fair share of the memories for executing other important processes. So that is the zombie process. So basically, sometimes you need to restart your system as a whole. Maybe, I mean, then it clears it off. So basically, to answer this question, the zombie processes are terminated or completed process that remains in the process table. Does it make sense to take away a process memory when it enters a zombie state? Why or why not? So what do you think? Does it make sense? Does it make sense to take away the memory of a process? Are you able to take away the memory of a process as a user?
I guess if you, like you said, if you just shut
No.
everything down, it can take it away. But
Yeah, I mean, if you terminate it, you don't do that. Basically, you make a system call, right? Somebody else was asking, is saying something as well.
Yeah, I said no. It doesn't make
Yeah,
any sense to take away the memory.
right.
It's
Because
already allocated. Taking it away would just waste resources.
right.
So
It
the
will not.
parent process really should call it back.
Right. You're right. I mean, that's the right approach, I believe, because when you have something, when there is a zombie process, so you want to, if you take away that memory, then basically, yeah, that memory is not available to do anything else. So that memory is gone. Now, if you terminate the parent process, then what happens? It basically it clears up most of the cases. It clears up the process table, and then the processor, that the kernel will no longer allotting any memory to it. So that way it will that memory will be reclaimed. So only way you can reclaim the memory of a process, of a terminated process, if kernel clears it off. For example, uh, let's think about the memory. I mean, like you have the pages, right? Pages or segmentation. So let's say the pages, the equal block of memories. So you have something on the process table. So it is some memory blocks are allotted with it. So what happens if you simply set aside those memory blocks? you take away the memory blocks from that process, I mean, that process is still there. So it will capture further memory because that memory is taken away from it. So as a result, increasingly more and more memory will be gone. But as a user, we cannot do that. I mean, we cannot simply take away memory from any process. All we can do is to terminate that process. And if that doesn't work out, we can terminate the parent process. If that doesn't work out, we can restart the system. That way, everything will be refreshed. So it doesn't make a sense um, to take away the memory of a process when it enters the zombie state. The only way it makes sense, I mean, only way to get reallocate the memory, claim that memory, is to clean up that zombie state from the process table. So it's you need to be clean out. You need to clean everything out so that those memories are become they become available again for other processes. So there are a number of daemons running on most Unix systems, including Linux. Identify 5 daemons and provide a short description of each one. So what you could think about the daemons? What are those?
On those, the ones that will work, behind the scenes,
Yeah,
like,
exactly. Yeah, that's the right answer. I mean, daemons run behind the scene. That's running in the background, right? So, so it says that, what is the question? Identify 5 daemons and provide a short description. So how do we identify the daemons? Let's say example. I mean, so basically they are asking you from the example. So if you let's say, let's open this Linux operating system. Let's do the top. So you can see here that many background processes is running. So you can say, I mean, pretty much like whatever runs, we need to identify certain daemon processes. So what are the, how do you identify the daemon process? That's the next level of question. How to identify? So can we identify a daemon process using some memory stamp? I mean, using some PID, the process ID. How do you find the? I mean, how do you find the daemons? So basically, first of all, we are doing multitasking, right? In the operating system, multi-programming model. So so basically, each program is running at the time it is called the process. So every running command starts with at least one new process. There's a, I mean, whatever you do, like if you do ls, that will be a new process. So in the same way, everything starts a new process. Now each process is identified by a number. You see here, PID, these are the PID. Let's do top. So you will see the PID, that is a process ID. And each process has its owner and the group. And group and owner permissions are useful to identify which files are devices related to the process. Now, there are some background processes as well. The special process, for example, so if you see the PID one, I mean, this one is system. I mean, basically it is the system D. It's called. It's a background process. This one basically. So this is an example of the daemon process because it runs in the background no matter what happens. If it is gone, then your system will be shut down. There are many processes like that. So it may not be useful to use. I mean, it may not be it may not be initiated by any user process. It runs with the system itself. Now we have to find out 5 examples of the daemon processes that we can do some searching around. Examples of 5 daemon processes in Linux.
I put like named,
Right.
send mail,
Okay.
NMBD, squid and route.
Yeah, I mean, those are the daemon processes because no matter what, those processes will run in the background always. The email server is basically what happens. Email server is a multi-threaded server. So it will be an infinite loop of threads. So it will keep running. Yeah, I mean, if you look around, you will find a lot of daemon, I mean, examples of lot of daemon processes. So it's up to you to list them. So just go around, that's Google the list of the daemon process, and you can see, I mean, list of daemon processes in the Unix. In there, they list everything. Like,
There was a
well,
lot of them too.
yeah, it's a lot of them. Yeah, I mean, there is no shortage. So just here, for example, here. So you can basically go through them and just write some explanation from, I mean, you can search it from here and just do it, just write it from here. So for example, HTTPD is a very famous daemon. Whenever you run some web server, then you will find that HTTPD is running always behind the scene. LPD is basically for the printer, this one. If you have some printer mounted, same way named, it's a DNS server daemon. Then postfix is a mail transport agent. Routed, it handles the routing tables. I mean, so a lot of daemon processes there. SMTPD, it stands for simple mail transfer. So sometimes the daemon processes are identified by the word D at the end to notify them as the daemon. You see, I mean, a lot of processes, they ends with D. That is an identity of a daemon process, but that is not a requirement. That is not necessarily, that does not need to be like that. So let's see if we find any daemon process on our system. So where is that here? So you see here a lot of, I mean, like, I don't know what is this. So this is a daemon process, system D. That is a daemon process, of course. But then I don't think we have the mail server running here. So here, this is also a daemon process. It ends with D. Then, yeah, this process runs continuously. This is also a daemon process. Let's see. Yeah, I mean, things like that. K-thread is a K-thread D. It's also a daemon process. So, I mean, there are examples on your system, but if you want to answer your question, you can find it from the uh, so if you find it, then I mean, it's best to find it from the website. So this is one of the webs. What happened to that browser? Did I kill it accidentally? Yeah, here. So I can send it to you.
I think
Uh,
that's where I went.
yeah,
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 yeah.
yeah. That's a popular link. Yeah, of course. Yeah. So let me put it in the chat. So we know what we were talking about. What happened to it? Okay. My Teams is not behaving correctly. Okay, that's fine. Hopefully it will not become a demon. I mean, not become a zombie process. So I sent it, but it is not yet there. Yeah, now it is gone to you. So once you go to the Teams channel, you go to this class group, you will find the reference to that. So that's about the daemon process. Now let's see what is that. I mean, if a Linux file has protection mode 755, okay, what can the owners group and everyone else do to the file? This is a very popular question. In fact, if you are planning to do the Linux certification anytimes, this is the question you will face, no matter what are the other questions, because this is the most fundamental thing any Linux administrator would know. So 7, we know that there is a rule, right? I mean, there is a rule regarding um, for read it is 4, for write it is 2, for execution it is 1. So if you sum them up, that is the number you assign to each privilege. So you have 3 tiers of privileges. First tier is the user, you own the file, your privilege. Second is the group where the file belongs to. Number 3 is basically anybody else. You are not a user, you are not within the group where files belong to, then anybody else with that category. So here 7 means 4 plus 2 plus 1. I mean, it has all the privileges. So the owner can read it, owner can write to it, owner can basically execute it. So that is the privilege for the owner. Next is 5, that is for the owner's group. So what is the privilege? 5 stands for 4 plus 1, right?
Read and execute.
Right. And what happens to the everyone else?
They get to read and execute it too.
Right, exactly. That's the answer. So yeah, go ahead. Any other
I was
question?
gonna, I was gonna say, if you're not part of the group or you're not the owner, why would, I mean, I don't understand why anybody else would, who is not in the group or the owner, would get to execute anything if they're not in the group.
Okay, okay. For example, you work for a company, okay? Now your human resource wants you to view their um, let's say email policy, but they don't want you to modify it, and you are not a part of the group that decides about the email policy. So from the file point of view, you are not the owner, you are not the or not a part of the group that can edit the file. The owner can read, write, execute. The the group can only read or write. For example, I'm giving you an example, not concrete example. They cannot execute something, but there is a third category, the common employees. They can only, let us say, read. So that is the purpose,
Okay.
you know.
So like if you're reading the policy of
Yeah,
sexual harassment or something, you can read it,
exactly,
but you
exactly.
can't add nothing to it.
Right. You cannot do
Oh,
any modification to that. So that's an example for
okay.
such. Why would you need that basically? So in the Linux system, I mean, it is done in that way. In Windows, it is done some different way. So there is always difference. So instead of 755, if I say 754, then what would happen to the everyone else? What privilege do they have?
Uh, they can read it.
Right.
Oh,
So if I do 75714, let us say, so what will be the group members privilege? I'm just
uh,
making it up.
they can execute it, but they can't read and write.
Right. Yeah.
Oh,
I mean, it is possible, highly possible. They don't want you to see what is there in the file. You can only execute it. Let's say you have the ls, I mean, the listing the file. And for some reason, let us say the owner of the system do not want you to view the source of that. Maybe you have written a shell script that does something. So the owner of the shell script doesn't want you to view the shell script. They can only allow you to run it and get your job done, get it done, and that's it. So in
or,
that case, yeah, in
or it
that
could be
case,
one, or it could be one of those ones where like the accounting doesn't want the employees to see what the other employees make on their hourly wages or something.
right, right, right. Of course, yes.
Oh,
Maybe, I mean, sometimes you see that in a system, let's say you are in a school system, the teacher cannot show the individual courses, individual grades, but that happens to the elementary or middle school, or I mean whenever the children go to the school, they can always share with the parents that your student is your student is among top, let's say top 10 students, but they cannot share what is there inside. How do they calculate top 10 students, or what are the contents, who are the students? They don't share that information. So in that case, you run a program and it gives it to you. Otherwise, they can navigate a list of the students and they say, well, this person is one, this person is two. So basically putting the security across the information. That's the goal. Okay, so I think we knocked down this one as well. So um, if you have taken some note, you can plug it in. Otherwise, we can make it up, and then we will also need to have some understanding of this one, detailed understanding of this one. Basically, if you can write the result, that will be done for you. What you can do here is that you can create a file XYZ and then put RT sometimes, some multiple times, whatever, and produce the result. And in another scenario, you can put XYZ and you don't create XYZ, then you will see all zeros everywhere. So these are the two alternate scenarios. If you put the screenshots of those two, that will be satisfied. But then we will go through more detail about these comments in some upcoming sessions. So let's give a break. Let's come back around 7:06, 15 minutes break, and we will pick up some quizzes after that.
Oh,
And there is no way I could, I could play all the quizzes, but I think that most of the quizzes will be discussed. And of course, you have options to, it's an open books quiz, so you can open your book and learn and answer the quizzes. Because most of the things, the most important thing here is why we set the quizzes. The main purpose is to learn. It's not the final exam that you will be basically put some, you have to go through some examination and then score objective assessment. Quizzes are also objective assessments, but behind the scene, the main purpose is to learn. So that's all about the quizzes. So yeah, we will go through the quizzes in the next session, and then we will see if we could revisit some of the assignments that we have some leftover. If we have some questions, if we can discuss some details about the operating system. So let's but we have a strong focus on the hands-on assignments, because that is the thing. Linux, when you do the Linux, it's basically 100% technical, 100% hands-on. So that's what we are trying to accomplish in this class. So yeah, let's give a quick break and let's come back. Welcome back. So this hour, let's go to the quizzes. So let me see what are the quizzes for the modules, this module. Let's see. So again, just review your your dashboard, your modules section. If any of you find that these attendance quizzes are not in order, let me know. I mean, I'm in touch with IT to find out why for some cases the quizzes were out of out of sync. So if you also find something odd with this attendance quiz, let me know. Okay, so let's see the regular quiz. So Linux quiz, and yeah, that's the one. Let me try to pull it up here as well. Just a second. I'm just logging into my system. Here you are. I'm just making sure that we are not simply editing the quiz. We are securing it. We are not modifying anything here. So if I go there, okay. Okay. Let's preview it. So again, I mean, preview means I'm treated as a student, but you see here, there are 25 questions. Yeah, there are 25 questions you have to answer here. So maybe we will miss some questions from the superset. Anyways, let's go over whatever is here. What contained in a program stack when it starts up? So what do you think it should be?
Both the shell and the command line.
Both the environment shell variables and the command line type to the shell. Yes, right. So we have to understand the difference between the program and thread. We are talking about the program. That means it's a process. So it has the environment variables, not the local variables. I mean, applicable to the threads and the command line interface. Yes, that's the right answer, because only environment variable doesn't make sense, because it's a program. So it should have some, I mean, instructions, arguments, all those things. And only command line also incomplete, and nothing is not an acceptable answer as well. Yeah, that's the right answer. So next question is, what is advantage of using memory mapped files? What do you think? So they are faster than using input output system calls. So what is a memory mapped files really? What does it mean? Um, so basically the files, those are stored in the local memory, let us say. So the memory basically, what happens, the files content is mapped in the memory as well. So they are faster when using input output system calls. Well, I mean, when you do the input output system calls, we first start with the cache, but really, um, I mean, if you have a normal file that is also input, it really doesn't give you any advantage, because you are not, you are after all using the input output calls. So they are easier to use than input output system calls. Well, I mean, they are easy, not always, because it depends. It depends on where. I mean, if you have a network system, very big network, then that may make sense, but not always. They provide a high bandwidth way for multiple processes to share memory. Maybe, because that may be the right answer, because I mean, when we talk about operating system, we are in a multi-program model, multitasking model. So they can share a single cache, the memory, and that way they can move. They allow processes to execute code from a file. No, I don't think so. I mean, that's a very oversimplification of the scenario. So I think, I mean, number 3 is the right answer in the screen, on the screen. What is the third segment of Linux process address space? So what is the third segment? So, I mean, what are the segments, first of all?
They're the ones
Segment,
that are,
what?
they're divided up into small pieces.
Right. But what is the third segment of a Linux process's address space? So the address space segment of address, I'm just looking at the book. address space. I know that we touched base about it, but I mean there are different pictures. I'm trying to find out a picture, a relevant picture for that. So I don't see any logical space virtual. I mean those are not the right thing. I think I mean in general this is the stack. The answer is stack. But you know, I mean you have the text, you have the data, you have the stack, you have the array. So so Linux process address space, how it is configured. Let's try to find out that in the book. I mean, I'm showing you how you could navigate to the book to find a given answer. Let's do that exercise. So I'm going to share my screen. I'm signing in, and then here. This is my book space. So this is my bookshelf, and I should be able to find out the Linux in the top. So here, so my question was, oh no, that's not the one. What is the third segment of Linux process address space? So I should go to here and do a search, address space. So here it is. Let's see what we have, the address space, CPU, the notion of an address space. Okay, address space is a set of addresses that process can be used to address memory. So Linux, I think we have some pictures here. Limit, no, not this one. Swapping, we went through those things, operating system, but that's a memory allocation, address space. Let's no. So, I mean, I don't find it any obvious answer to this question from the book itself. Let's focus on the address space, and it is relevant for chapter 10. We know that for sure. So let's go to chapter 10, overview of Linux, memory management in Linux. Let's go there. That's their text management. So basically you have the text management contains the machine instructions from programs executable code. So then it is the text management. So data segment, then comes the data segment. The first one is the text segment. Then comes the data segment. Then let's see the third one. So third one is the stack. That's what we were talking about. The stack space, the stack pointer. And the final one, there is an array, right? I mean, we have so basically, let's see, memory map. So fourth one is the array, basically. Oh, I'm sorry. So, so what happens here is that when you have a Linux, you get the textual instruction from your command line, and then the textual information, the textual information is transferred to the, I mean, it is transformed into the data. So um, your data part, I mean, there is another segment that stores the data. Then you have the stack, that's the memory, that's related to the memory where you put all the essential information. And then the array is all such, I mean, all the information, everything in details. The final stack is the array. So stack is the third segment of Linux processes address space. For whenever you have a Linux process, you have text, you have data, you have stack, and then you have the array of all the memory allocations. So do all operating systems immediately kill all processes created by a terminated process? That's a very good question, actually. Um, I mean, that's an that's we discussed briefly in the zombie process. So you see here, yes, all operating system work this way. Well, that may not be true. Uh, no, either Unix nor neither Unix nor Linux works this way. Only Windows works this way, only Unix works this way. So basically the second one is the correct answer, because when you kill a process, what it does basically, killing is a system's call, right? I mean, as a user, you trigger a system call that goes to the kernel, then kernel processes that instruction, and then the memory is reclaimed by a uh, by a I mean by some daemon process, background process. So everything doesn't happen very all everything doesn't happen immediately. It takes little time to clean up everything, and things settle down. So that's why if you kill something, you won't see immediate effect. It will sometimes it takes little time to make the system back to the normal stage. So second one is the correct answer. What is the additional advantage of mapping a file uh, into a process's address space? So mapping a file into a process's address space. So it allows multiple processes to access the file simultaneously. I mean, we talked about it. That is true. It makes random access to the file easier than using input output calls. That is also to some extent true. It provides a high bandwidth way. Yeah, that's what we discussed in a previous quiz. So all of the above is the right answer to this question. How are new processes created in Unix? Wow, it's a big description. So new processes created in Unix. So this is a very big description, the second one.
I think it's the first one because he talks about the fork system and then executed by the
Yeah,
fork
yeah, yeah.
system.
Right, right. You have to. You were right, actually. I appreciate your answer because you identified this. I mean, these keywords basically, because this one actually is too big, but there is no material in this answer. Yeah, that's right. I mean, it is the fork system call and also the exe CVE or similar process. So you see the right terminology there. So that is the correct answer. So how do Linux systems support shared text segment? So this is a little bit tricky. So by keeping 2 copies of the program's text in the memory, of course not. I mean, it is not supporting that. Why 2 copies? I mean, by mapping the text segment of a program into the physical memory, that's what it does basically, because it maps the virtual memory into the physical memory. By using MMU hardware, no, then it's not a hardware process. By sharing the text segment with the environment, no, of course it's not it doesn't work that way. So yeah, second one is the closest to the all answers given. So it maps the text segment of a program into the physical memory, because I mean this segmentation, everything is virtual. It is programmatic. I mean the program organizes things in this way so that things become easier for the kernel to execute. So that is what is done here. Yeah, that's the second one is the correct answer. Now, the next question is Linux is primarily designed for servers and not for suitable. What is your comment on that? This is the easiest question, I believe.
Things false.
Yeah, right. It's not just server, right? I mean, it's um, you can use Mint and you can use CentOS. Mint is primarily designed for the users, CentOS for the servers, for example. So yeah, so it's false. Now, how does Linux handle dynamic memory allocation during execution? So that is important. So basically by using the BRKC, I don't know what is that. I mean, I don't think that is the right answer though. By making heavy use of C library procedure malloc. Yeah, because it's written in C. So, I mean, this is the close answer because Linux is written in C language, and malloc is a process in the is a library in the C language that actually allocates and deallocates the memory. In C++, it is done differently. In C++, it's done by the pointers. And I am very scared of C and C++ language because of these entities, because they are horrible. I mean, horrible means, I mean, as a programmer, you will have very tough time to understand those. And as a programmer, it is hard if you put something in the code and you find that it is running out of memory, then that's a nightmare to locate that, especially in a big code. I mean, in the C or C++, it's very hard to locate the problem. In Java, it is much simpler because you don't worry about memory. In Python, same thing. All the modern languages have a way to claim and reclaim the memory automatically. And that's why they are slow, by the way. I mean, Java, JVM, and Python, let's say Python interpreter, those are extremely slow, because um, eh, because you assign everything to their garbage collector model, and the garbage collector is a multi-threaded process, so there is no guarantee. If you want to trash some memory, destroy some memory, recycle some memory, your garbage collector needs to reclaim and needs to collect it. And this is a multi-threaded program, so there is no guarantee that it will be picked up immediately. But in C, for example, or C++, since it is done by you, I mean the programmer by hand, if you do it correctly, then it's extremely fast because C++ is very close to the hardware. It uses directly all the, I mean, hardware software interfaces. So the system calls, it works very closely with the system calls. So that's why it's called a low level language, and that's why it's very fast. But anyway, long story short, I think the second one is the correct answer because it's a C library procedure. I mean, whenever you see Linux and with some programming language reference, and if it is C, C++, if it is C, then that is the correct answer all the time. What is the name of special process in Unix that is present in the boot image that initializes the system? So yeah, that you should be able to guess, or you should be able to answer this question.
The
In
first
it,
one,
What?
the first one,
The first one is the init. I think that is the right answer. Yeah. So Unix, I'm trying to make sure that we are indeed. Yeah. Init is the first answer because kernel is not a process. It's a component. And then shell is at the user level. I mean, once we log in, then comes shell. The login is also a program. I mean, it's a process, but it is a user process. So init is the first process because when you boot up the system, the init is the first process to run. Then comes when are data and stack segments shared between the process. So when are data and stack segments shared between the process? When two users are running the same program, that's not the true case because two users may have different perspectives. The data cannot be copied from one user to another user. Then after a fork, but only those pages that are not modified. And then always is not answer, never is not answer. So second one is the correct answer. So basically, you create a you do the fork. I mean, you create another process out of the process, and then um, the pages that are not used, those are only I mean only things that the data and stack segments are shared. Because if a page is being used, then that belongs to that particular thread. I mean, the user is a thread, right? I am a user, I'm writing ls, so I'm creating a sub process out of ls. I mean, things work in that way. So I mean, that's pretty much it is. or I mean, I'm a user, so basically I'm living in a different address space, because that's how the computers manages multi-user processes. Each user is it is like each user is a thread, different thread. So they are the same process, the operating system, those are threaded into different users, and then you can claim you can use the ls, I mean that listing of the file, but then it is applied to a different data. So text is the same, but data is the different. So it applies to all the remaining part, text, data, then you have the stack, then you have the arrays. So your text is the same ls you are using, but if you use different arguments, then text is also different. So basically the answer is, I mean, the after a fork, and only those pages that are not affected or modified. Second one is the right answer. How are uninitialized local variables handled in the Linux memory model? Uninitialized local variables. So those are very interesting. Uninitialized local. So
think it's-
basically, yeah, go ahead, attempt.
I think it's the third one.
What is that? Uninitialized variable are ignored and not allocated any memory, but they, I mean, if you are familiar with C programming model, or let's say any programming model, sometimes when you have, I mean, if you have a local variable, not the global variable, local variable, and that is uninitialized, then you usually get an error. You know, your compiler always complains that you did not initialize it. So I think in that case, the
B.
second B is the
Yeah.
correct. I mean, because
Yeah.
they contain unpredictable or garbage values, because if you don't initialize, it can contain anything. I mean, the system will randomly assign a value. That's why the compilers, the leading compilers, they basically error that out in order to avoid that scenario.
Oh, is that where the garbage in, garbage out would be for the second one? If it's not initialized, then you throw in something that's not supposed to be
Yeah,
there, and then you
right,
get that information back.
right.
Um,
Yes. So what are the two parts of the data segment? So we are talking about the data segment. So what are the two parts? So initialized and what initialized and what is that? Initialized data and that the first one doesn't make any sense. I think the second one makes sense. First one is the I thought it's a typo, but it's made to fool us around.
It's
So yeah,
B.
the third one doesn't make sense at all. So yeah, it's a B. Uninitialized and initialized and uninitialized data. What is the main function of the shell in Unix? So to provide a graphical user interface, no, not really.
Okay. Interface between user and operating system, right?
Right.
Number C.
That is the right answer. Yes, you are right. So how many segments in Linux process address? We already talked about it. There are how many?
3.
3 or 4?
3 text data stack, right?
and array.
Um, array is not counted as a different
Oh.
segment. It is the collection of those artifacts. Like if you have text, you have data. I mean, you have memory, right? I mean, the stack. It is a collection of the memory. I mean, everything is collected inside the array. So I think the 3 is the right one. 3 is the right answer. What happens if a data or stack segment needs to grow, but there is no room adjacent to it? That's a good question. So the process crashes, not always. I mean, the operating system moves adjacent virtual pages to free up space. There is no problem since adjacent virtual pages do not have to map onto adjacent physical
I think it's
pages.
C.
C is the correct one. Yeah, right. Because I mean, I know, I mean, I mean, sometimes that's the benefit of the virtual memory, the virtualization, that you don't have that much memory, but it can accept that work, and then it can put it inside a buffer, and then gradually it processes that work using the physical memory. So it will be just, I mean, it will be subject to some scheduling, some allocation, but there is no problem in that. Unix was designed by programmers and for programmers. Is it right? I don't think it is the right answer.
I
What do
think
you
it's
think?
true. Yeah.
It's true.
I think it's thought.
Um, well, I mean,
It was
what is
designed by programmers for users, wasn't it?
right? I mean, it is true. I mean, it's very confusing. Unix was designed by the programmers. That's true. And for programmers, that's also true. We do the programming with the Unix, right? I mean, any operating system. This is designed for the programming purposes. I mean, we run the programs on the operating systems only. We don't do anything else. I mean, even if we play the game, it is a program as well. So yeah, that's right. So then, which segment of Linux processes address space contain the machine instructions that form the program's executable code? So that is interesting. Machine instructions that form the executable
It's text, I believe.
text. Yeah, ls, for example, ls minus l. Yeah, that's the text. You are right. Because data is not the text, because it can be binary, whatever it is, but it's not an instruction. And stack is much lower level. Stack is the way how you store the data. And if we think about the arrays, arrays are a variation of the stack. How can a program discover its argument? That's a good question. How can a program discover the argument? So arguments are what? Uh, they are stored as the local variable, right? When you run a thread, then I mean, for example, if you have a program ls, then it has a thread and it has the local variables. So I think the local variables goes to a local variable goes to stack.
Yeah.
So that's the correct answer. So then what happens when a user puts an ampersand after the command in the Unix shell? Did we try that? Um,
It runs in the background, right?
yes, the and sign. Yes,
Yeah.
that runs in the background. Yes, of course. I was little confused initially. What is ampersand? I mean, it's the and sign, and symbol that runs in the background. What is the purpose of a static zero page in the Linux memory model? Static zero page. So static zero page is basically third answer is correct, to provide a write protected page full of zeros for use during the initialization. So it has basically it supplies you the zeros. Similarly, you can get the nulls as well. Uh, I don't know how to use the nulls. I mean, maybe it's in this when you declare the global variables that's assigned a null value originally. So I mean, you have zeros, you have nulls. I mean, you have different pages in the operating system. Linux is based on monolithic kernel architecture. I'm not sure about it. Monolithic kernel architecture. So what does it mean? Where all the operating system services run in the, yeah, of course, all the operating system runs in the kernel space. There is no layered architecture. So I think this is a true statement, because you have the user space, you have the kernel space, and kernel is the operating system basically. So there is no hierarchy within the kernel. There are, but it is treated as a single space. So it's a monolithic kernel architecture. How are the system calls invoked from C programs? Um,
It's the first
so,
one. Call in the library, right?
right, yes, right. You call a library. That's right. Then what is the primary purpose of Linux memory model? So Linux memory model, if we think about this, so to make programs portable, um, that's true because you are putting the program in the cache and then you can use it from anywhere. To make it possible to implement Linux on machines with different memory management units. Yes, because if you have Linux can stay on multiple machines, including the virtual boxes, to allow for the use of sophisticated paging hardware. That's true. I think all of the above is correct one. What is the current working directory in an operating system? Um, the directory where process was launched from, directory where a file was created, directory where process is currently executing, directory where path names not beginning with the slash and look for. I think fourth one is not correct, of course, but
I think there's a second one.
second one, no, actually, I see the answer. I mean, they say that the fourth one is the correct.
Yeah, I was gonna say, I took this and that was the fourth one because I got it wrong.
Yeah, the directory where path names not beginning with slash are looked for. The directory where path names are not beginning with a slash are looked for. So current directory in an this is quite confusing. What is the current working directory? So what you do here is where path names not beginning with a slash are looked for. So what is the current directory? CD. CD is the current. By doing the CD, you do the that's a change directory, but you can see always your current directory where it is there, where the file was created. That's not the right answer. Directory where a process was launched from. That's also, you can launch a process from any directory and move to different directory. Directory where the process is currently executing. That is also not true. So I think, I mean, that's why you can eliminate all the four, all the three, and that's, although the number four is not very promising to me. I mean, it's not very self understandable, self explanatory, I would say. So these are all the questions that showed up to me, but there may be other questions as well. What is the main function of a shell in Linux, in Unix? I'm not showing those questions, but there may be a question like that. What is the main function of shell in a unit? Let me try to share this question. Try to find some way to share the question so that you cover
That's
everything.
the interface. The shell is the interface, right?
Right.
Between
Let me.
user and OS.
So these are the alternate answers. So I think
To run the editors and the compilers.
no, I mean, it runs other things as well. To act as, you just said, right? I mean, we actually covered it. To act as an interface between user and the operating system. That's what you said. You said that, right? It is an
Yes,
interface between
yes.
user and operating system. Yeah. So let me see if there is other question, any other question than I think we discussed that. Well, init kernel. So let's see. No, I think we got all the questions here. We addressed everything. There is no overage. Let me see. No, I think we all have these many questions. So we are good. So yeah, I mean, if you have made any mistake, then do it again, second time. So note it. I mean, basically, if possible, go through the lecture and just do the submit it correctly. So let's give a break now, and at 8 p.m. we will work on the other quiz. this one. I mean, Git on Mint Linux. So we did a lot of stuff involving the GitHub. So this one is meant for that. So let me open it up. So preview, yeah. So what command do you use to initialize a new Git repository? That should be very straightforward. Which one is the right answer? Any suggestion?
Get in it.
Right,
Oh, yeah.
right. Git init is the right answer. Well, I mean, I don't know. Okay, yeah, I mean, there may be some confusion with the answer, but we will work on that because I see the correct answer is noted as git add, but the correct answer is git init. So we will let me try to fix this one because really it's not the right answer. Let me do that quickly. Just where is that? Here. So yeah. Just a second. Let me correct it so that people know. Okay. I submitted that. I mean that request. So then the question is, what command do you use to check the log of commit? That's interesting. That's a good question. We have we done it? We did not do that, I believe. So we
Yeah,
do
we
the
didn't get one.
yes. So
Would it be
basically,
Git
what does
log?
it say? Git log. Yeah, I mean the Git log will do it for us. So let's go to our GitHub repository. Let's do that. Test 1, 2, 3, 4. So if I go there, let's say git practice, and then if we do git log, then you can see that I mean there is only one like only one thing I have done here. Nothing else I have done here. So that's the answer. That's the log. So what command do you use to create a new branch? So I mean we did I mean you could use git branch command. You could use git checkout -b. So just git checkout is not sufficient. So I think the git branch is the right answer to this question. I mean, we did the git checkout, but we put an argument -b that will ensure that a new branch is created. But just git checkout would change your branch. It will not create a new branch. Okay, so git branch is the right answer. If git is not installed, what command do you use to install it on your Linux Mint machine? So
Third one?
yeah, is it the git or GitHub? I mean, I think the git is the right answer, right? I mean, let me I forgot it. So basically, if git so is not installed, so basically sudo apt git. Yeah, this one is the right answer. Yeah, that's what it says. Fourth one is not right. This is the GitHub is the repository name. I mean the website, and GitLab is the website name. But Git is the main program. Basically, it's a program. It's not a It's not a product, or it's not a web page. So GitHub or GitLab are the web pages. So what command do you use to stage a new file for commit? Yeah, that's a good question. What do you think? You
Git
did
add.
it. Yes, you add it to the repository. Yes. I mean, after that, you can do the commit. So pre-commit is the adding. So the main purpose behind developing Git was to help developers to create small to very large projects in collaboration with other developers. Is it true or false?
True.
Yeah,
True.
it's true. Yeah, it's a repository, right? I mean, it's for sharing the code. Yes, both answers are right. What what command? I mean, both answers are right means, I mean, both of you answered it correctly. What command do you use to check the status of the repository? It's simple.
Git status.
Yes, right. It is easiest to install Git on Linux using the preferred package manager of your Linux distribution. It's true or false?
I would assume that's true.
Yeah, it's true because we did that, right? apt-get that command. If you would do it from the website, then you have to install some executable, then you have to run that executable. So, and then you have to worry about that executable matches with your operating system, a lot of things. This is the easiest. So what do you check if Git is installed? How do you check if the Git installed on your Linux Mint machine? How do you do that?
Git version. Git dash
Yes.
version.
Yeah, that's what I'm thinking.
Yeah, version is the right. I mean, any program actually, when we install it, is the best way to check it using the program name dash dash version. Some flavor, some combination, some flavor of that. Like Java, same thing. So Git is also the same thing. How do you check if Git is installed in your, okay, that's we did. What command do you use to delete a branch? We did that.
Remove branch. Git remove branch.
Think it twice. I mean, we did that. I mean, in our program, you also did that.
Git branch minus R.
Minus
Yeah.
R, what is R? No, I mean, you were just distracted a little bit. I mean, git branch minus D for delete, right? So you use the git branch minus D command to basically process that.
Minus R is the one when you want to remove anything inside of a file or a directory.
Let me check. I mean, I forgot it. Git branch minus R. Yeah, that's a good question actually. So this will give us opportunity to review everything.
At least that's what I remember.
Yeah, let me see there. I don't see this, any comment like that. Let me see again. Git branch minus R, right? I mean, Git creating, deleting branches. Let's see. Git branch usage. So there is nothing called git branch minus R. So if you see here, um, different options, git branch is it lists all the branches. Minus D deletes, minus capital D forces delete the branch even if there are unmerged changes. Minus M is moves or renames. Minus A is list or remote branches. So there is no such command like minus R. So that's about it. Yeah, minus R is. I mean that's not an option for the Git. Okay, so I think we knocked down this one. Let me quickly check if we have any additional questions so that I can tell you that example. Status initialize, that's right. Git is not installed. Okay, what do you check? Git is installed. That's fine. Yeah, I mean, that's all the questions we had there. So yeah, I think we wrapped up the quiz as well. this is the easy quiz, one of the easiest quizzes. So remember, there is nothing called git minus r. So that's
Oh.
a good takeaway from here. So that's the one. Let's see, what's that? Linux quiz chapter 10. Okay, we did the discussion. Did we do any discussion? I mean, that's everyone does it. So I'm not opening it up here. Let's open it. Let's see what's going on here. Different discussions. Yeah, I mean, this is an ongoing ensemble of the post. So let's leave it as it is. So I think the only thing that is left over is not this one. I believe that we did not do that. Is it the one package management? I mean, the last part that is the 15 and 16. I still need to figure it out. I mean, what is the package you should be using? There are many packages. So you have to do uh, install a package from source code, configure it to run on your system using the following commands. So sudo apt, so build essential is fine. It's the build command. So, but then you have to download some package tar.gzip file. Let us try to find out, try to locate something. Let's see. Let's knock it down as well. So then we can utilize the time tonight to knock it down. So let's say Apache, what else? Apache C++. Let's see. C++ standard. No, I think so. What is the download? Let's see. We don't need to download the standard library, but we can do uh, install from source code C++. Let's say what with Apache. Let's say if there is any such example, install and set up Git. No, we don't want to set up Git at all. So what else? Building, okay. I don't think this is a good option. Install a C++ package, and we can do install a C++ package from source. From source tar gzip Linux example. Let me see if they have any ready-made package somewhere. Installing the GUIs. No, we don't need that. What else could we do? Connector C++ from binary distribution. Let's see. Installing on Linux. So what is there? Oh, installation using a tar. Installation on Mac OS. We are not using the Mac OS. So, but this is a binary, right? I mean, installation RPM package. We want to use the to install the compressed tar file. So what is there? We need to have some C package, and then we have to use the Mac tools. So that's the thing we have to find out. So what else could be available? You can also search along with me so that we can uh, parallel stream this work. C++ tar gzip file to download and install. Okay. No, exif2, that is not that. Okay, log4j maybe log4 C plus from source. Is a simple to use C++ logging interface. So what is this? Download, if we go there. So what do we have there? Log4 C plus documentation. So download from SourceForge. So we can do that. Tar gzip, where is here it is. So let me try it out, then you can try, because let's see, I mean, if it works out or not. So I think what we should do, that is not sufficient. I mean, I think we have to go to the Linux Mint, open up this one, this Firefox browser. Okay, download. We can write download log4 C++. Okay, so there's a downloads folder. So let's try to follow that process now. So let's open up the terminal here. So let's do this one. Mkdir C plus log4 C plus. So let's do log4 C plus, move from download folder.
Do we
Uh,
have to download it from that site that you had it on?
Yeah, I mean, that's I can send you the link, but I'm not sure it is a genuine one. That's why you could wait until I do it myself, then you can do it. So let me put it there in the link. So this is your log. Is it? No, this is not the right one. I'm sorry. This is not the correct one. Let me find out from here. Here. So this one is the right one. I put a wrong folder in the chat. So now I put the right folder in the chat. Yes, I mean, you can download, you can try as well. I mean, there's no problem in trying it out. So you have it here. So here. So now what you need to do is basically we have to, uh, I mean, we have to try those steps. So what we can do, uh, but this is XZ. Is it the XZ that we want? Maybe we want something different. Let me see what are the other options we did have. Let me see, go back. Okay, so here it is, log4 C plus download. No, not that one. Yeah, I saw that there. Yeah, this one we want. Actually, we want tar gzip file to make it accurate. So yeah, now we are good. So we can go to the terminal and then right now let's remove this one. Let's move it from downloads log4 C plus .gz. So here, so if we do that, you have this file. Now let's do tar minus z xvf. So basically z means you are unzipping this, minus z, you are unzipping it. X is extracting. V is you are going to view the status, I mean detailed things, and F is all the files. So if you do that, you did that, everything is done. So you have a log4 C plus folder there. Now what you can do, so you cd to the package name. So that's what we did. Now let's do configure. So yeah, that's done. After you do there are errors as well. I mean, C compiler cannot create executables. What's happening here? For whether the C compiler works? No, the C compiler doesn't work. So let's see how we can make it work. Linux C compiler apt get. So let me see. So basically what, so we did the build. Oh, I did not do the build essential. You did. Sudo apt install build essential. So I'm putting my password. Yeah, yes. So this is the necessary step. I think it will be corrected after this, because when you do the see GCC, CPP, everything is um, applied now. So we are downloading the build essentials. Okay. So now we have, let's see, GCC -v. If we do, you have the C++ stuff. So configure. Now it is very rigorous. You see, everything is generated. I mean, it's a configure is a script basically within the Linux. It runs. It's a build tool. It's called the build tool. This tool can be generated. You don't have to create the tool. I mean, there are certain commands that will help you, but that's out of scope here. So let's see, configure. If you look at it, oh, nano, sorry. So you have this type of script. I mean, this is auto-generated. Let's not worry about it. It's a shell script. You can, if you see it, it's a shell script basically. It uses different system resources and does the things for us. So it is given to you when you generate a package in C++ using some system. So that is the configure, and then you have to do make, I believe. Let me see what is the next step. Next step is to do make. So make means you are building the package. So you are compiling, you are doing everything that it does. It reminds me of my old C++ days. It used to be fun all the times. We used to explore a lot of different packages and open source things. I mean, Log4 C plus was one of them actually. In fact, I took up this package and modified it for my organization to do some project. Problem was their C++ was older than the one that is supported here. So I had to downgrade that one. I had to downgrade this one to be compliant with their project. So that was the beauty of the open source project, because I mean, I could get the open source code from them and then I could modify the code and make the changes. It took quite a time. I'm like about a month or so, but it was very rewarding experience. But I mean, most of those things I forgot by now, but it was, I can remember that those works. So it is executed now. So it is doing, I mean, it's a lengthy process. I mean, it is compiling all the different code base that is under here. Okay, it's done. Then you can do sudo make install. So make install assures that you are installing the libraries out of it. So it is done. So let's see. So if we go to, um, let's see what it created. So there is a whole lot of package structure it created. So if I go to lib, is there any lib folder? No. So let's see. Install is here. Install program is here. And then how do I find the particular file? So I think we have to go to, it listed this one, right? Log4 C plus, this one, user local lib. um, so here, user being installed. So if you can go to cd user binary install, user not binary necessarily, user lib. So if we go there, let's see, C plus, no, no. So where do we install it after all? So if I go there, cd, and then go to log4 C plus, HL. So yeah, log4 C plus, and then if I do that, so let's see socket test. I mean, all the things are there. Okay, missing make file. So if I edit the make file, that is more make file. So where do we put it? I mean, after the make install command, this one actually, this one is created somewhere. So I am trying to find out lib log4 C plus, this stuff must be created somewhere. So if I do that, unit test thread. So if I go there, unit test, let's say, oh, that's not a, so if I go to test, so here, so if I go there, test suite, vi test suite, then it must be pointing to the lib, no lib, rep minus I lib log4. So log4 C plus file, where does it put it? So we can do like this. I'm trying to find out the directory where it is gone. So you should expect a SO directory. So where is it? Is a directory? Okay, that's fine. So once source dep directory, so that's that's the place you have it here. So what is dep directory? Let's see. Compile watch, config status, lib. Is there anything called lib? Let's see the directories. So if we do that, directories, scripts, test, thread pool, this is that one. So we have M4 lib tool, include is the initialization files. So cache, CYG port documents, and then we have include, then we have, we don't care about iOS. I don't know what is M4 though. That's it. And then scripts. So we did the sudo command. So that means it must be there somewhere. User share lib. Um, lib, it should be somewhere. I mean, lib, Louis lib, okay, user. So you have lib, you have bean, you have whatever, local, maybe local, lib. No, it's not the one. We should be looking at user local, not local user. Then what else is there? Share is not there. Lib is not there. So lib 64, is it the possibility? Where is it? So it is that. No, not that one. Where is a library stored in Linux? Where is the user library? So basically you have user local lib 64. So you have user local lib. So you have this one. Yeah, here it is. So go to cd user local lib. So it's a local library. So you can see, I mean, we just to see the timestamp, we just installed log4 lib log4 c plus here. So this is the ultimate library that we will be using if we use log4 c plus. So that's basically the one we created right now. So you should be also able to do that. I mean, it's seamless. It's simple. If so, the critical step was to get the build essentials. Once you get the build essentials here, the build essentials, this one, build essential, then everything else should be very simple. So we can use the log4 C plus, the one we decided. So why do I see so many messages? Let me quickly.
I just tried it. I tried the second step after the sudo, the first one, the get install build essential.
Mhm.
And
You get error.
it told me it can't tar child log4 plus dot tar dot gz cannot open.
Okay, can you
No.
go, can you share your screen and let's see what we can do about
Oh,
that. Share it. Okay. So what is going on? Oh, okay. So probably your tar file is not there. Can you do ls? So what is, I don't think it is there at all. So you downloaded it, right? Then you create a folder called log4c plus. You downloaded it. So yeah, it is in the downloads folder. If you have downloaded, now do mkdir, m, yep, space log4c plus, enter. Then go to log4 C plus. Okay, now you can do basically uh, you can do the build essential. You already did that. Now let's do tar. I mean, move first. Let's move the tar folder. Move mv space dot slash download capital D, downloads capital D, and then tab. if you tab it, yeah, downloads, no, move downloads, and then you have to put the file name.
Oh.
Move downloads. I mean, you can use page up arrow. Yeah, then log4, start with log and then press a tab. Yeah. What is that? T, put tar, T, tab, dot gzip, gz, tar,
TC.
tar, 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 dot gz, G for good. Yeah. And then space dot. So you are moving the file here. Enter. Oh, what's happening? Did you download that one? tar.gz?
Oh, yeah, I thought I did.
So is it GZ or XG? What did you download? No, can you not? Yeah, this is the one we want. So where is it? Where is this file?
I have no idea.
Okay, can open the file. I mean, can we go to not? Okay, so it is under where? Slash. That's too odd. Let's do one thing. Let's go to your navigate to your downloads folder. Go to your terminal. Open a new terminal. Yeah, open a new one. Yeah. So yeah, let's focus on the, yeah, that's fine. CD and then downloads, capital D, downloads. Yeah, LS. Okay. So you have it here. Looks like log4 C+. So let's go back there. Go back your previous terminal, the one you were using. No, not there. I mean, you have it there open somewhere.
You know, this one or the other one?
The other one, the one you were using, you got error. Yes, here. So what is, oh, not 2.2.0. So can you do move? I mean, can you do the up arrow, page up, and then yeah, no, not that. Page down, page down. Yes. Now backspace. Put your backspace. No, not the one that way. I mean backspace. You need to erase. Keep erasing.
Oh, like deleted?
Yeah, delete it. Yes, right. Yes. Okay, that's fine. That's fine. Now let's do tab. Tab. Press tab. Okay, press tab again. Can you put 5 there? Oh, say 0.5. Yeah. Can you put 5? Number 5. No, I mean there is a pipe there, so we need to put 5.
The number 5 or
Number
FIVE?
number 5. Backspace as well. No, not that way. Yeah. Now write, enter 5, the number 5, and then tab. Yeah. Then put a dot. Enter. Good. Now you can do the tar XVF, CXVF. So you can do your back, I mean, page up a couple of times again. Yeah, this one. So no, but it is not the right one. Backspace, put delete this one until you reach the dot. Go back. Yeah, now go back again. I mean, yeah, dash and then tab. You will find it. It will find everything else. Yeah, enter. Okay. Now the next step is /configure. Configure. Yep, enter. What happened to this? Oh, no, sorry. You have to do cd log4 C plus. Do a cd, then tab, do a tab. Yeah, tab. Yeah, enter. Now do a page up couple times. Yeah, enter. Yeah. Now it is generating all the resources for you. It is creating the make file, everything for you. So when you see an empty directory, it doesn't have anything. I mean, this tool actually configures your folder,
Oh, okay.
preparing it for building. Yes. Now do the make. So this is a part of the build essential. Make is a binary. It's a command. Enter. Okay. Now it will happen.
It looks like what you did so far.
Right, right.
So I messed up where I didn't make the directory first. And I should have made the directory first.
Which one? What is direct reverse? I don't understand that.
When you made after you did the get installed build essentials, you did you made the login for thing, and then you had to change to that directory.
Yes, I mean that's right. I mean what you did there, you did the tar extracted that tar ball basically. You extracted that compressed folder as a part of the extraction. It is I mean it is the contents are stored in a folder that is called log4 C plus. So you had to change to that file, to that folder and get all the things. So when you compress, you can compress a directory as a whole. So that's the way you structure the things. Same thing applies for zip in the Windows. I mean, it's no different.
So zip file is just a compressed file where it makes it's still a big file, but it's just compressed it to make it look like a smaller file.
Yeah, right. It's a, I don't know what is, it can go up to 1/4 of the size.
Oh man. I mean, I've used it, but I've never actually paid attention to what it did.
Yeah. Okay. So that's it. I mean, now if you go to CD, do a CD user /usr/usr/usr usr/local slash lib, enter,
Oops. I didn't hear that last one.
enter, just enter.
Oh.
ls. So why it is just Python? For me, let me see. Is it the right place? I did user local lib. Yeah, it should be there, right? Oh, we missed one step. Sorry. So do a CD. We did not install it. CD, and then that's it. I mean, enter, and then go to log4 C plus, CD log4 C plus, tab, CD space, and tab, enter. And now you can do make install. What happened here is not a directory. Oh, what's going on? Include, sudo make install, I think. Sudo make install because you don't have permission. Install, enter. Okay, password. Enter. Yeah. So now let's do cd enter, no, /user usr /local /lib, enter, ls-l ls-l. That's it. That's where your final product is. So you successfully install a library.
Oh, cool.
Yep, that's all it is. So everyone else, any feedback, any comment? Did you do that?
I'm a little bit.
I couldn't hear you. You just got muted.
Oh, sorry. Yeah, I'm still catching up from yesterday's, but I'll get there. I was
Okay.
able to download it into a folder, so I think I understand the next steps, and I'll run them
Okay.
later.
So we did the next level of the bash script. So here we did a lot of like the password. I mean, we use the system programs, a lot of the programs in the Linux operating system itself. I mean, some third-party libraries, OpenSSL, and then we did the space usage. I mean, that's the DF thing stuff, and then the monitored system usage. These are the simple commands. So this one, and then we did a lot of this one. So we completed this one. In fact, I mean, we started with some packaging stuff, and then we ended with this making. We are now able to compile any C++ program on Linux. I mean, we can download a tarball for a Linux and basically compile it and install the library for that one. And then we discussed about the takeaway journal. I mean that the different aspects of the different conceptual aspects of the Linux operating systems. And what else we did? We also worked on the quizzes. That's another important part. I mean, we worked on the quizzes and pretty much all the answers were discussed. So I think that I think you should be able to take it up from here and start submitting the assignments. And I believe that, I believe that those who are following this class should be able to complete those assignments pretty fast. I mean, you can go through it interactively and solve the assignments, submit submit your assignments in time. And that's it. I mean, I think that's all about it. Don't forget to submit the attendance quizzes if you have not done those already. I mean, there was an issue with one of the assignment quizzes, the scheduling of the assignment quizzes. I forwarded that to the relevant person who is taking care of that, and it's I think it's now resolved. And also the quiz answer, the git init, that one also got resolved. I mean, we were able to take care of that. So you should be answering the right way. I mean, the git init, and you will not, this won't be a mistake for you. So that is another stuff. And what else? I think we pretty much wrapped up our stuff for chapter 10. So basically, the Unix system, I mean, hierarchically, we started with the Unix system. I mean, if you look at the history of evolution of Unix-like systems, we started with Unix, then the Linux came into the space, and then we improved the Linux. Still improvement is going on, There are a lot of different flavors of Linux, and I mean, the Linux can operate in server mode as well as the user mode. So it supports the GUI as well as the server side components as well. So that's the beauty of Linux. And then we have explored a lot of command line features. Now, any of you, if you are interested in doing any certification on Linux, I mean, I'm just going to give you a very brief overview, not the certification, but more, I mean, where you can learn more about Linux as far as the commands goes. So you should go to, sorry, you should go to LPI. So LPI is called, I mean, this is an organization, Linux Professional Institute. They provide a lot of, lot of certifications for the Linux. So, sorry. So this certification, there are 3 levels of certification. You can see like Linux Essential. I mean, that is the thing that we started to discuss in the class. I mean, different commands. Then you have the security essentials. I mean, how to install the security patches. Then web development essentials. And these are the essential part. And then you can go to different levels like professionals and then the open technology. A lot of different stuffs. So if you look at the Linux essential, it has very unique goals. Let's see, I mean, the exam objectives, and that is also very important from the point of view of your learning, because you can go through these and you can practice the command lines, things like that. So basically it has basically 5 sections: the Linux community and career path in open source. So you will be discussing a lot of distributions, a lot of embedded systems, a lot of cloud, how it is used in cloud. Then we'll be talking about different like flavors of Linux, Debian, the Ubuntu. Then we did the CentOS, right? And that's what we did. OpenSUSE, Red Hat, uh, those things. Then we already did the Linux Mint. You can also have scientific Linux. Those are pursued. Scientific Linux is mostly pursued by the scientific organizations, the universities, I mean, all those organizations. Then you have the embedded system like Raspberry Pi, Raspberry, and also the Android. I mean, we touched based about the Android. Our week 5 will be mostly focused on Android system. I mean, this is also a variation of Linux operating system. Now you will be able to learn a lot of open source applications. I mean, there are desktop applications, server side application, the level development languages like Python. We are, I mean, those languages are distributed along with the Linux. The package management tools, that's what we did, right? I mean, dpkg, apt-get, those are all package management tools, but those are discussed in details. The used files like LibreOffice, we have we have installed LibreOffice yesterday. We already have Firefox. We already talked about GIMP a little bit. We were used for searching anything that contains GIMP. A lot of things. I mean, Apache. We downloaded part of Apache. Then I mean it talks about the open source and licensing. I mean, I'm telling it because I mean this is a certification which is not very hard to obtain, but you can, I mean, this certification has a lot of value in the industry. When someone, I mean, even employed with system admin role, they can upgrade their, I mean, knowledge base, as well as that is good for the promotion, getting promoted. I mean, these are very, this certification is a good one. Uh, then there are open source discussions. Then the skills, basically, what are the skills that you need to work in Linux? So those touch bases that part. Then the second topic is finding your way on a Linux system. So it talks about the shell system that we talked about, the bash shell. So basically around those topics. So you see here the bash and then echo, I mean, history, I mean, all those different commands. We did not go through all the commands, but we talked about the bash shell. We did a lot of scripting. Then the manual pages, the man pages, there are two different levels of manuals. One is man pages, another is info pages. So feel free to just explore your Linux Mint, do the man, let us say ls, info ls, you will see two different levels of information there. Then the directories and listing of the files, we did that. I mean, the command, we use those commands to navigate across the directories, created the files, listed the files, all those stuffs. These are the common commands that we have used. Then the creating, moving, and deleting files we did. I mean, those are the commands, simple commands. You have already learned those commands. I can say that all these commands were practiced in this class. So, I mean, this is so trivial. So then the power of command line. This is the most important part of this exam. You will be able to go through the files, directories, the archives, compression. I mean, all those things. The tar, we briefly touch based on the tar gzip system. So we touch base with this command line, the essential part of that. The searching and extracting data. So we did the grep a lot. Uh, we did not do the less cut, I mean, all these comments, but we did the WC, the word count stuff. Then we wrote the script. I mean, we did a lot of bash scripting, the simple bash scripting. This symbol is called the shebang. I mean, if you call it, if you are after the terminologies, then this is called the shebang. This particular symbol called the shebang. And then you have the Linux. We talked about, I mean, we already talked about it, but it touch bases about the Linux operating system. So, I mean, like difference between different systems, the distribution lifecycle management, like you said once, there was a question that how do you keep up to date with Linux packages? So it discusses about those things. Then the hardware, little bit of hardware, the motherboard, processors, power supplies, little bit of everything. Then the storage system, all the different storage system. We already handled those commands like yes, top. We did not do the free, but you can do it yourself. You can do the, I mean, there are different directories that are discussed here. Now, networking, this is one of the most important stuff. The networking, in the networking stuff, I mean, why we want to learn that basically whoever is the system administrator, they have the responsibility to make the system exposed to the network within the limits of the firewall, within the limits of the security protocols, and also to prevent the system to be infected by malicious viruses, things like that. So that's why learning the networking is so important for the Linux. You can see different protocols, different comments to troubleshoot different issues. Then the security and file permissions, we did that. I mean, we did a lot of chmod. I mean, there are different parts of that. So important thing is we created the user. Then there is a file called etc password. Then we have the etc shadow. So a common confusion between these two files. etc password basically contains user information, whereas etc shadow contains the encrypted password. But the encryption is made in a way that if you have a Linux system, this is the one-way encryption, because you create a password that will be encrypted and stored in the etc shadow, but anybody else cannot decrypt that password. Even the root user, the system admin, they cannot do that as well. So those things, I mean, those are discussed as a part of this exam. The creation of users and groups, you can see, I mean, I'm going to show you the study resource as well. So, I mean, if even if you not for certification, if you study the book, that will be helpful. So then we have different comments. The chmod, we already discussed about chmod. Then we have some discussions on special directories and files. I mean, all this stuff. So you have access to its study material, which is very helpful. I can show you. There is a study material. So learning materials is like that. So there is a PDF version and also online version of each topic. So if you do the PDF version, let me put that in the Teams channel, because this will be some additional learning, not that it is related to within the, it will be asked in the current uh, like course, but it offers you to learn more on that. So if you look at the Linux Essential, it is full of bare essential information about the Linux systems. Like you can see, I mean, you can go through different topics, the embedded systems, everything. The beauty is like you see here, Android system. So these are the summary of different systems. So these are perfect. This is a perfect book for crossing the barrier of the interviews, because in the interview people mostly ask you about the basic questions. So if you, for example, if you are up for a system admin interview, just go through that. I mean, Linux admin interview, go through this book and you will find all the all the brief discussions about all the topics that Linux, as far as the Linux goes. I mean, there is nothing beyond this book that is covered within Linux. I mean, everything is covered with a very brief perspective. That's the purpose of this book as well as the certification. So this is a very good study resource. I mean, you can see a lot of guided exercises. Why guided? Because the answers are given at the end of each chapter. So it gives you the answers of the exercises as well. So that will give you enough opportunity to learn while you study those things. And the most the positive thing is, once you learn it, you should be able to do the certification as well. So that will it's not a very intensive study intensive certification. You have to be careful about the multiple choice questions as well as different parts of the uh, I mean comments. So I mean, anybody's, if any of you is interested, let me know. I mean, I can give you more materials relevant for this certification. um, so yeah, that's the book. I already shared the URL with you. So that's pretty much, I mean, what I wanted to talk about today. I want to know if you guys have any questions.
No, I'm having trouble loading that log4c, but I'll go through the recording again because I was a little behind. And if I have any questions, I'll reach out.
Okay, yes. You reach out to me and I will be helping you with any questions that you might have. And
Thank you.
next, yeah, no problem. So next week is the finals week. So I think we wrapped up most of the, I mean, all of the week 4 topics. So I think the next step for you this week is to wrap up your stuff. Like if something is left to be submitted, just submit it. And if you see that some grade is missing, reach out to me. I mean, I will try my best to make everything up to date, so that when you go for the finals, you will see all the latest grades and you will know exactly what to look for. I mean, what to do in the final, what levels of grades you should be doing in the final, you should expect in the final. And also don't forget to like review the quizzes. You can go through the lectures and review the quizzes, because each final quiz will be a combination of all the different weeks, the topics, different weeks quizzes. So that's a superset. So we are seeing the subsets of these quizzes. So basically, those quizzes that we covered during the past weeks are important for us. That's why. So yeah, that's pretty much it is. And what else? I mean, is there anything else that you think I should be covering today?
I think I'm cool.
I think I'm good,
Thank-
sir.
Okay. So then, yeah, I'll be around doing some grading, possibly this week. I will keep myself up to speed, going through your discussions. And if you have any questions, you can ask me. But yeah, I mean, I'm here until 10:30. So want to stop by, I will be here.
Oh, thank you.
Okay.
Thanks for that website. I'm gonna look at that website too, and
Yes. Yeah, I know.
uh,
This is interesting. Yes.
I don't know which one's more difficult, this or
It's not. I did
no.
it. I did it. It's not too difficult.
Oh, okay.
All the things you have to do is to. I can send you more study materials for that. I mean, there are free quizzes available everywhere.
Oh,
Like the Cisco Net Academy. That's a. I can show you actually. Net.
yeah, when I went to school before, tried that Cisco one for the networking.
Yeah, the same thing. I mean, like this login is free. I mean, you can create your account, just like I have my account set up here.
Oh, sweet.
And then this one, I will give you the URL to that. So
That
that,
Cisco was pretty difficult for me. There
oh
was a
yeah,
lot of information on it.
right. But this one is not. I mean, the good thing is this is the exam. Actually, this is the Linux Essential. And it is going through all the details. I mean, you can see each section, each chapter, it is so good. And you will see a lot of quizzes at the end, exam. Each chapter ends with an exam. There is a midterm exam. There is a final exam, end of course, final exam. Then once you have the final exam, two final exams, one for subset of the modules, one for all modules, and then you have the labs as well. So basically, if you go to the labs, you won't even need to get your own Linux Mint, because these labs are basically, if you go to the labs, this is your Linux on the right hand side. So
Oh,
it is a virtual system, and then you can pretty much do whatever you want.
just
Uh,
practice right there, huh?
yeah, right. You can do whatever you want. So this is that. And you have all the instructions here. You can read through it, and then you can do the tests. And this is the best study material to get prepared for this certification.
Oh yeah, that's really really cool. I think I think I might like that.
Yeah,
'Cause
that's good.
when I went to another university 10 years ago, 12 years ago,
Hmm.
they didn't have stuff like this.
Oh
So
yeah.
you just had the book, and you just had to go to like half price bookstores or bookstores and get other stuff to read.
Right.
I still have books from 12 years ago on my bookcase.
Yes, I mean, the books are good up to certain extent, but when you are turning into your technical stuff, then hands-on is more helpful. And
Yeah.
then these interactive books are super helpful, because you see here, you have the books here on the left hand side, and you have your computer on the right hand side. So it's very, very handy, and it's Cisco. Basically, they have the expertise around this topic. So, so that's about it.
Yeah, they didn't have stuff like this. Because sometimes reading the book I'm okay, but then when they use all these technical terms and stuff, it's
Mhm.
kind of hard to remember it, and then
Yes, yes.
get a lot of the hands-on stuff. And
Yeah,
I'm a
yeah.
hands-on person.
Yeah, every one of us. I mean, like we should be, because we are all related to the software development or information technology, and it is the hands-on subject. So
Yeah,
conventional learning process does not always work here. I mean, you read a book, memorize something, do the exam. That's a good thing, but it is not very helpful all the times, especially
yeah,
if you are in IT, information technology.
yeah,
Yeah,
yeah. I
yeah,
agree with you. It's like you
yeah.
need to do the book, and that's why a lot of times when they have examples in the books, I do the examples while I read because it helps me understand a lot better. So
Yeah.
that way, when I do take the quizzes, do the labs or the assignments and stuff are a lot easier.
Yeah.
To where if I just read it, then it's like, okay, half the stuff I read, but I can't remember if I was awake while I was reading it. You're trying to do the osmosis thing where you fall asleep with your head on the book.
Yeah.
And so yeah, the hands-on is great. And it's like
Mhm.
I don't see how people can just read the book and remember all that stuff and they can go take the exam. I can't
Yeah.
do it.
Yeah. It is not very helpful as well. I mean, you will forget. Eventually, you will forget those things. But hands-on stuff, you will remember forever. Mostly, I mean, like the Makefile stuff, I did it long back, like 15 years ago. I was doing those, but now, I mean, whenever I started doing it, initially it was a little bit looking for what is this, what is that, but then everything is simple. So
And
yeah, that's the beauty of this.
yeah, and that's the part that worries me is if I do get the job, whether it's online or at a physical building, is
Hmm.
like going there now is like, what am I supposed to do?
Yeah.
I don't want to be the new guy that, okay, where's that at? And it's
Yeah.
like, hey, y'all gotta let this guy go. He doesn't even know what director we were on. It's like, well, I don't know how y'all work yet. So at
Yeah, I
least give
mean,
me a break.
there is a keyword for starting when you start a new job. There is a convention I follow. I mean, first, let's say first 1 month, it is your turn to ask questions. You can ask whatever question you want, but then people will ask questions. So ask
Yeah.
you questions. So first month is very good for whoever is joining for you, and then bug them in all aspects by asking the questions, real questions, and you get the answers. And then what typically people do, I mean, I do, is that create a personal knowledge repository. I mean, like we all have Microsoft Office suite. I use the OneNote. That is a very useful interface, and I put all the, I mean, essential information there that is
Oh,
very easily searchable. So anytime something happens, I go through my notebook, and always I find the answers. I mean, if I don't find, I go ask someone, and then whatever that person explains, I put it in the notebook. So next time I find the answers from there. So
yeah.
that is very useful, I found.
Oh, thank you for the I gotta remember that for when I get a job. Ask a whole bunch of questions and just write everything down.
Yeah,
They can
yeah,
call me a dork all they want or a nerd. I'm writing everything
whatever.
down.
It doesn't matter. Yes, yes, you're right.
It's like, yep, I'm a dork. I'm writing it down.
Yeah, right.
Because I'm the type, yeah, I'm like that. I want to, and then I'm pretty sure, after a couple of months, they'll hire new people,
Hmm.
and those people will come and ask you questions, which also can help because you can tell them what the other guys told you, which
Hmm.
helps you remember,
Yeah,
and then you might learn some stuff from the new guy too.
right. Of course. That's the collaboration. Yeah, that's right.
Is thank you for all the information. It's all rolling around in my head right now. I don't know when it's going to get organized, but
Okay. Yeah.
thanks, thanks for all the information.
Okay. No problem.
Y'all have a good one. I guess see you next week unless I have a problem.
Sure. Sure. Yeah. Yeah. Tell me anytime you have a problem, we can jump on the screen and we can solve it together. No
Uh,
problem. Yeah.
Thank you, sir. I don't know about everybody else, but I used to be the guy a long time ago that I know you're supposed to ask questions, but I didn't want to be the guy. And I'm asking questions, I guess, is sort of like being the comedian. The comedian talks about the embarrassing stuff, and
Hmm.
that's why everybody laughs is because the
Yeah.
ones who are laughing, those experiences happen to them, and that's why they're laughing.
Yeah.
And sort of like asking questions. everybody's probably got the same question. It's just that they don't want to feel stupid or something to ask the questions. I'm 50 something years old now. It's like, I'm not playing that I feel stupid thing anymore. It's like, if I got a question, I'm asking, and then hopefully it's a question that somebody else has too. You know?
Right.
So I'd be the dorky, nerdy, weird guy who asked the off the wall question, and I'm just asking it just to be on the safe side, you know,
Yeah.
just in case I might need it.
Yeah.
You know? But thank you. So y'all have
Thank
a good
you.
one.
You too. Yeah. Talk
See
to
you
you.
later.
See you later. Bye.
Bye bye.